Now we're going to analyze the market. We're going to inject shocks into some market and see how prices and quantities change given that shock. We call this comparative static analysis. And the statics here are the equilibrium. So we have a static position that's called an equilibrium, okay, or steady state. We're going to inject a shock into this market. One of these curves will shift, a new equilibrium will be generated, and then we compare the two static positions with regard to equilibrium price and quantity. So did equilibrium price rise? Did it fall? Did equilibrium quantity rise? Did equilibrium quantity fall? Etc. Uh, Now, I'm not going to go through an exhaustive list of potential shocks because we covered those in the previous lectures on supply and demand, the demand curve shifters and the supply curve shifters. So we're going to go over some of them, but not all of them. So let's start. Okay, so assume that we have the market for cars. Okay, and specifically the market for new cars. Okay, now assume that the price of steel in this market falls. Okay, so the price of steel falls. We would assume steel is an input into the car industry. And as we know, one of the supply curve shifters is a fall in the price of inputs. So we also know that a fall in the price of an input will increase the supply of that product. It will shift the supply curve rightward to a new supply curve, say S prime. Now, question is then, what happens to the price of new cars in the industry and the amount of new cars on car lots nationwide? Well, the obvious intuition tells you that, well, the price of cars should fall. And there should probably be more cars on car lots. Having said that, I'm going to state this now, and please, please retain this information because it's important. The shift of a curve does not change the price of a product. Let me say that again. The shift of a curve does not change the price of a product. Demand or supply could shift all they want. The price of the product will not change. The price of a product only changes if there's an inefficiency in the market. In other words, if there is a shortage or a surplus of the product. That is the only time the price will change, because if the market is efficient, there's no incentive to deviate from that point. That's something I pointed out vividly in the last lecture. So how do we analyze this shock to the market, a fall in the price of steel, an input to new car manufacturing? Well, let's assume that the price of a typical new car is, say, $26,000. Okay. Well, if firms keep that price at $26,000 and they increase the number of cars out there, well, they're going to have a surplus of the product. And why are they going to have a surplus of the product? Well, because since demand didn't change, quantity demanded is still there. But quantity supplied is over here. And so the rest of this is a surplus of the product. And we know that's inefficient, and we know that the way the market would want to get rid of this inefficiency, of course, is to reduce the price of the product. As they do, they increase the quantity demanded of the product, but at the same time, they disincentivize automakers from making as many cars. So what do we end up with? We end up with a lower price for cars, and we end up with a larger quantity of cars on the market. Okay, so comparative static analysis here would say that prices fell and quantities rose. Let's take another example. Let's look at the market for butter. Okay, so there's the supply of butter, there's the demand of butter. This is an original equilibrium price of butter, say per pound, and this is how much butter is on the market at that price level. This market for butter is currently in equilibrium. Now let's change the price of margarine. Specifically, let's increase the price of margarine. Well, we generally think margarine and butter are substitutes, as we discussed in the last lecture. Margarine is a lot cheaper than butter, and many people can buy a large tub of margarine for the price you can buy just a few sticks of butter for. But generally, people think butter tastes better, and so if butter was cheaper, they'd probably buy more of it. So cheaper in a relative sense, that is. So let's assume that the price of margarine rises. Well, then in the margarine market, quantity demanded of margarine will fall. This means that the demand for butter will increase. It will shift rightward. Now, if butter manufacturers keep the price of butter at P star, then they are still only going to be willing to put Q star units on store shelves. But at that price level, you're going to have a far larger quantity demanded of the product. And so you're going to have a shortage of butter. We know, again, that's inefficient, and so butter manufacturers want to rid themselves of the inefficiency. They don't want to leave any money on the table, so they raise the price of butter to a higher price, and they increase the amount of butter they put on store shelves, okay, to re-equilibrate the market. So in this case, comparative static analysis would say that prices rose and quantity rose. Let's do one more. Okay, let's assume we're looking at the market for let's assume we are looking at the market for laptops, laptop computers, okay? And the market is originally in equilibrium, say at $1,000 per computer, and there's 2 million computers on the market. Right now, again, quantity supplied equals quantity demanded, meaning the market is efficient, okay, at that price level. Now, we would probably consider laptops a normal good. So let's assume that that the federal government decreased everyone's income taxes, which increases their take-home pay. Well, some people may just go out and buy a laptop with that additional money. What does this mean? Well, if laptops are a normal good, you get an increase in your income level, you should see an increase in the demand for that good. Okay. And just like over here for butter, only the shifter was different, the dynamic is exactly the same. You would get an increase in the price of laptop computers. You would also get more computers on the market, and once again, price rises and quantity rises. Now, we can complicate this picture somewhat. I mean, you can see where all this is going, and your book covers examples of this. Here's some examples here. But we can complicate this picture. Let's assume we get two different shocks to a market. Okay, so I'm going to erase these. Let me erase all of this. And assume we get two shocks to the market simultaneously. What does comparative statics tell us about that? Well, let's assume we are looking at the market for new homes, and this is the equilibrium average price level of a new home, and this is the number of new homes on the market. Now, let's assume that the price, let's assume that a a bug, some sort of wood boring beetle, hits yellow pine forests in the southeast and basically wipes out a lot of the yellow pine in the southeast region of the United States. Well, yellow pine is a primary input into the construction of new homes. This, of course, would increase the price of lumber, which is an input into the new home process. And we know that that will cause a fall in the supply of new homes. Now, this single shock here predicts that, comparative static analysis predicts that prices will rise and quantity of new homes will fall. Now, at the same time, let's assume that the government issues an additional tax credit to already their existing tax credit of being able to claim the interest on a home loan on your taxes. Let's assume they want more people to own more homes, and so they provide an incentive for people to purchase new homes by allowing an additional tax credit. Well, this to a great extent is like an increase in the income level of individuals, and new homes would obviously be a normal good. So we would get an increase then in the demand for new homes. Okay. Now, this increase in demand, if you ignore the supply change, the increase in demand would predict that prices would rise and quantities would rise. Okay. Now, putting those two together, what do we actually have? We actually have a movement from equilibrium number 1 up to equilibrium number 2 when we put those two shocks together on the market. In other words, we definitely get an increase in the price of new homes with those two shocks. However, we cannot tell what will happen to the quantity of homes on the market. And the reason is because the first shock would lower the quantity of homes, but the second shock would increase the number of homes. And so without additional information, such as assume that the destruction of the wood forest that pushed the price of inputs up, assume that impact was greater than the demand curve shift. In other words, than the tax incentive shift. Well, then that would mean that this curve shifts more this way, and you would see a fall in quantity of homes. But without that additional information, we simply cannot tell what happens to Q, and we would just say Q. Change in Q is ambiguous. We just don't know. We do know prices will rise, but we don't know what will happen to the number of new homes on the market. Let's go over one more. simultaneous shock. So let's assume that we are looking at the market for motorized scooters. Okay, so what you see people driving around on roads a lot these days. So obviously, you can for instance, drive a scooter, or you can drive your car. Okay, scooters probably get far better gas mileage than your car does. Okay, so driving a car and driving a scooter are substitutes. Let's assume that the price of gasoline falls. Okay, so the price of gasoline falls. Now, if the price of gasoline falls, you will probably drive your car more. Okay, you will probably drive your car more, meaning that you will drive your scooter less. Okay, you would get a leftward shift in the demand for your scooter. Okay, now let's assume at the same time that um, uh, uh, that um, 4 million scooters by some manufacturer have been recalled and simply pulled off the market. Okay, well, that's very much like you could categorize that as a change in the number of firms. You could categorize it as a fall in technology. Um, Either way, you're going to get a reduction in the supply of scooters. Now, once again, this first demand curve shift to the left caused prices to fall, okay, and quantities to fall. This supply curve shift, this leftward supply curve shift, if we ignore the demand curve shift, this leftward supply curve shift says prices rise and quantities fall. So what would our final analysis for these two simultaneous shocks be? Well, we were at equilibrium 1. We moved to equilibrium 2. We know that the quantity, equilibrium quantity of scooters on the market will fall. That's obvious. But because one shock pushes prices down and the other shock pushes prices up, the change in the price level is ambiguous without further information. Okay, so without me saying, or without someone saying that the supply shock was larger than the demand shock. Because if the supply shock was larger than the demand shock, the supply curve probably would have shifted out here somewhere, meaning that prices definitely would have rose. Okay, but without that extra information, we just can't determine in terms of comparative static analysis what happens to the price level of the product. Now there's a regularity here, okay? And here's the trick. If the shocks, that one shock per curve, okay, so one shock hits demand, simultaneously one shock hits supply. If the shocks are in the opposite direction, so demand increases, supply falls, or demand falls, supply rises, because remember I can reverse all this as well. So if the shocks are in the opposite direction, change in price level will always be clear, but the change in the quantity, equilibrium quantity, will not. It will be ambiguous without further information. On the other hand, if the shocks are in the same direction, so either a decrease in supply along with a decrease in demand, or an increase in supply along with an increase in demand, if the shocks are in the same direction, the change in quantity will be unambiguous, that will be clear, but the change in prices will not be. That will be ambiguous without further information. So this is comparative static analysis. You can have single shocks to the market, just like we went through, and you have clear changes in prices and quantities. Or you can have simultaneous shocks hit the market, whereby without clear available information, you're only going to be able to tell what happened to one component of the market, either price or quantity, but not both.